Hello, Algebra 1. Welcome to our first new lesson. Attached with this Google post is a couple other videos if you just want to see more examples of practice. And also, I have to say I'm proud of you guys. Out of all my 5 classes, you're the only one where I had 100% of churn in into the Google Classroom. So I just want to say I'm proud of you guys, and I wish you guys could keep it up, okay? All right, so 8.4, solving polynomial equations is our section today. Now, what's very strange about solving polynomial equations is this. I'm going to make one up real quick. So let's do x plus 3, x plus 5 equals 0. So I'm going to look at this at first, and I'm going to see something weird. Whenever we solved equations before, we only had one x. Back in system of equations, we had x and y, but do we have the same letter x? Let me see if I could distribute, and maybe that will help me see if it looks different. So we have x squared plus 5x plus 3x plus 15. That's x squared plus 8x plus 15 equals 0. Well, that still sucks because I still cannot get x by itself, because even if I move negative 8x here, 8x here, I still have an x on both sides. I can't combine these like terms. I can't really divide it for fun, because then this would be 15 over x. So I'm really kind of stuck in this situation. So we have to rethink our thinking. So let's look back to the original problem, which was, and I'll just erase it and rewrite it, which I believe was x plus 3, x plus 5 equals 0. Okay, so, we can't FOIL it, and it doesn't really fix anything. We still have two x's, and particularly x squared and x. And we have two x's here. But let's look at this. This says x plus 3 times x plus 5. So x plus 3 times x plus 5. So if that's true, if it's x plus 3 times x plus 5, and that's equaling 0, I have to tell myself, I know 0 times anything gives you 0. So with that in mind, for this one, what if I plugged in a negative 3 here? Let's just try a negative 3. So negative 3 plus 3 times negative 3 plus 5. Well, negative 3 plus 3 is 0, times negative 3 plus 5 is 2. And hey, that equals 0, because 2 times 0 is 0. So I just figured out that x could be negative 3. What if I plugged in a negative 5, though? So that's negative 5 plus 3. And then it is negative 5 plus 5 equals 0. So over here, I get a negative 2 times, over here, I get a 0 equals 0. Hey, that works out too. So something strange. I have two x's, and these two x's cause me to have two correct answers. X negative 3 and x negative 5. Why are they correct? Because if I plug in a negative 3 into x, I end up with 0, which was my goal. Over here, if I plug in a negative 5 in either one of these, in both x's, I get x is 0. What's very important that I think I could see a mistake happening, you cannot make the x's different values. You can't make this like 3 and make this one negative 5, or make this one negative 3 and make this one 2. Like, you can't mix and match. Since they're both x, they have to be the same number when you plug it in. So how did I know it was negative 3 and negative 5? Well, other than been doing this for a couple years, it's actually very easy. So here are your steps. I'm going to type up the steps in the instructions of the Google Doc or the Google post in the classroom, so I don't have to rewrite it here. So step 1. So step 1 is going to be this. I'm going to separate each piece here into two separate equations. I'm going to separate each polynomial. So that's going to be x plus 3 and then x plus 5. Because this equals 0, I can set these one individually to 0. So my first step is to split the polynomials and set each one to 0. From there, I'm going to do subtract 3, subtract 3. So I have x equals negative 3. And I'm going to do subtract 5, subtract 5. X equals negative 5. So that should match our question from before, where I plugged in negative 3 and I made the whole thing 0. And I plugged in negative 5, I made the whole thing 0. So this is how basic is the problem. You just have to split it up and solve it. Even if I had 3 of them, so I'm going to mix it up. So let me make 2x plus 3, x plus 5. Let's do x minus 7 equals 0. So then we're going to split this up into 3 separate polynomials. We have 3 x's, so we should surmise that we're going to get 3 answers. So 2x plus 3 equals 0. 5x plus 5 equals 0. And x minus 7 equals 0. Well, I'm going to subtract 3 on here and here. So I got 2x equals negative 3. Divided by 2, divided by 2. X equals negative 3 over 2. Well, that's one answer. Minus 5, minus 5. X equals negative 5. Well, that's 2 answer. And plus 7, plus 7. X equals 7. So for these, I hope you notice a pattern. When is x plus 5, my answer was negative 5. When is x minus 7, my answer is positive 7. So I want you to know that if you have no number in front of the x in this case, because here, over here, it was negative 3 over 2, so you kind of have to do the math here. But over here, it's just the flip of whatever the number is here. So if it was plus 5, the answer would be negative 5. If it was minus 7, the answer would be positive 7. So these factor polynomials are very easy to solve. You split it up, it equals 0. And I should say, and I put a little asterisk here, only works if it equals 0. So if this thing over here were to equal 2, I'm not allowed to do what I just did. If this thing over here were to be equal to negative 1, I'm not allowed to what I just did. The only way I could do what I'm allowed to do is if I start off with equaling 0 or I make it equal 0. For the first lesson or the first day, it will start off 0. All right, next part of the lesson is going to be factor out what's in common. Okay, so this one I find that people have trouble with, and I'm going to post an exterior video from another teacher or something I found on YouTube about this. All right, so what we're trying to do is take things out in common. So what is taking things out in common? Or what we call factoring. How do I factor out what's in common? Well, the steps are in the Google instructions, and I'll put it also, I'll just put it as a description in the YouTube video also. But the steps in order to do this is simple, but there could be mistakes. So step 1 is to find the GCF of the constants. If you don't know what GCF is, it's the greatest common factor. So I want to find the greatest common factor of the constant numbers, which is 6 and 15. So what number goes in both 6 and 15? You're right, 3. So 3 goes into both of here. So I'm just going to write 3 on the side over here, okay? I'm just going to write 3 on the side because it goes both into 3 and 15. And that's the biggest number that goes into both of them. Now, x cubed to the 3rd power, x to the 10th power. This is a little different. We're not looking for the GCF between 3 and 10. Remember, what x to the 3rd power means is that's 3 x's. Well, x to the 10th power, what that means, it has 10 x's. 5, 6, 7, 8, 9, 10. Okay, So when I said the greatest common factor for my constants, I'm saying what do they have in common? What's the most things they have in common? And the most they have in common is a 3. This guy has a 2, and this guy has a 5 left over, but 3 is what they have in common. And that's the biggest thing they have in common. So when I say what's in common between x to the third power and x to the 10th power, or any variables x, or any variable in general, I'm counting how many x's do they have in common. So we're going to count. There's 1, 2, 3 x's in common. And I want you to point this out. It will always be whatever the smallest variable or the smallest exponent of x is. So this is x to the third, and this is x to the 10th. X to the third, x to the 10th. So since this has 3 x's and this has 10 x's, what they have in common is 3 whole x's. So what's in common between x to the third and x to the 10th, and I'm going to write it over here, is x to the third power. No association that they are both 3. So this is x to the third power, and this is x to the 10th power. Okay, I just wrote what's in common here. So I'll put C for common. So this is my common stuff, right? Now, I want to factor it out. So I want to remove it. Let's think about this. When you do 3x plus 2, when you multiply it, you add it, or you put it in. We're trying to remove it. So if we multiply to put it in, we're going to divide to pull it out. We're going to divide to pull it out. And this is what factoring is basically is. So I'm going to divide 3x to the third power and 3x to the third power because they both have it in common from both of these numbers. So 6 divided by 3 is simply 2. X to the third, when you divide exponents, you subtract, becomes x is 0, which becomes 1. They're exactly the same. So however you want to think about it, it doesn't exist anymore. So this is just 2. Plus 15 divided by 3. 15 divided by 3 is 5. X to the 10th, x to the 7th. If we look up here, there are 7 that are not in common. So that's why over here, it's left over x to the 7th. I'm going to put this in parentheses. And just as a reminder of what I took out, I'm going to put 3x to the third power on the outside. Now, this right here is your final answer. And what I want to talk about is how this becomes. Because if I were to distribute 3x to the third to 2, 3 times 2 would be 6. X to the third times nothing is x to the third. 6x to the third. If I did 3x to the third times 5x to the 7th, 3 times 5 is 15. Hey, that was the original part. X to the third times x to the 7 is x to the 10th. So you could check your work by distributing. And one point I have to make, I think on the quiz, a couple of you guys mess up your distribution. Remember when you do exponents or variable to variable and you're multiplying them? So it's x to the third, x to the 7th, you add the exponents. So that's x to the 10th. So that's why it's x to the 10th here. I'm going to do one more example, a much simpler one. I made a complicated one for my first one, but let's just do a simple one. Let's do 4x to the second power plus, let's do 12x. Okay. So we're going to take out what's in common between the numbers first. So that's the constants here. So 4 and 12. So 4 and 12, what's the biggest number in common? Happens to be 4. Now we're going to look at the x's. You have 2 x's here, and you have 1 x here. So you have 2 fingers up on your one hand, and you got 1 finger on the other hand. How many fingers do they have in common? Not in total, but in common, just 1 finger. So because of that, we're going to take out only 1x because this guy only has 1x while this guy has 2x. So we're going to divide 4x. We're going to divide 4x. 4 divided by 4 is 1. I don't have to write that. X squared divided by x is going to be x to the 1 power, so I'm just going to write x. Plus 12 divided by 4 is 3. X divided by x completely disappears. So your final answer is 4x x times x plus 3. Tomorrow, I'm going to end this video now, but tomorrow we're going to actually apply the two things together. How do we make it equal 0? And what do we do with that situation? Okay. The homework be posted on Google Classroom. I haven't decided yet as of recording this video. Make sure to stay clean, wash your hands, keep your social distance, and have a wonderful day and relax.